Assalamualaikum and a good day to my lecturer. I RTS Shamrulma bin Shamsuddin. We are from Group 4. We'll present for the Integrate Design Project for the structure. So for the introduction, structure design is a methodical investigation to get the economical specification of a structure or a structure element to carry the predict load safely. Afcons Ltd is a company which provides professional solutions to any civil engineering related problems. Design of structure for the development of office building, which includes beam, slab, column, foundation, and stairs.
Okay, my name is Zul Ashraf bin Zulkifli. I will explain for the design schedule. For the first week, we're gonna go with course and project briefing, and then forming group of project, establishing the company profile, and obtaining the architecture driving plan. Which is in the first week, we will do much more for brainstorming and make sure that everything we do in semester will be smooth, and we will catch up for every single weeks. Then for the second weeks, we go with the creating the structure drawing plan, and then the determination of beam and column position, and then determination of dead load and live load. We make the criteria for the buildings and everything. For the week 4, 5, 6, and 7, we start with the manual calculation, which is the beam calculation, slab calculation, column calculation, foundation calculation, and design on Esteem software, which is we done using our own computer and PC. But for the manual calculation, we had our own beam and column for us to design separately for each one members in the group.
Assalamualaikum and hi. My name Ahmad Izra Kamal bin Baharudin. For today, I will present to you how we design manually. First, for beam design, the first step of beam design, we determine the maximum bending and shear first. From this value, we can design the main reinforcement according to clause 6.1. And this formula we are used for this design. Okay, for the shear reinforcement, also same procedure. We refer to clause 6.2 using this formula, and then for the next step is checking deflection. Refer to clause 7.2. We are using the formula, and then we compare the actual deflection, either is passed or not. Okay. Lastly, we check the cracking, refer to clause 7.2 by using this formula. Okay. After we get all the value, we do the detailing. For the next design is slab design. For the slab design, it almost same procedure like beam design. The first, determine the maximum bending and shear. Design bending reinforcement, referring to clause 6.1. By using almost same formula like beam design, and also design shear reinforcement, refer to clause 6.2.2. And next step is check deflection, refer to clause 7.4, and check cracking, clause 7.3.3. And then from this value, we are create the detailing for slab. Okay, the next, for the column design, the first step is to determine design moment first by according clause 5.27. The next step is check biaxial bending by referring clause 5.8.9. Other than for the next step, design reinforcement by referring clause 9.5. For this value, we are referring to design chart. From design chart, we can determine the area, and then we compare AS minimum and maximum. The AS value means either this value. Other than the last step is check biaxial bending by referring clause 5.8.9 okay, we are using this formula. The value must below than 1. If below than 1 is design column is passed. Okay, this detailing for column. The next design is pad footing. The first step, we determine the load analysis by using this formula, ultimate axial force, and then we design the main reinforcement, almost same design as beam and slab by referring 6.1. First, determine the effective depth by using this formula, bending moment, and from K value we can get the area of steel are required to support the pad footing to support the load. Other than from AS value, we do checking minimum and maximum uh, reinforcement area by using this formula. Okay, for the checking here, we have three checking. The first vertical checking, we are using this formula. And then for punching shear, we are refer to class 6.4.3 by using this formula. And then maximum punching shear of column at column parameter, we are referring class 6.4.2, 6.4.32 by using this formula. And then after all shear pass, we do checking and detailing. And here it is a detailing for pad footing. That's all for me. Thank you.
So, how to design in Esteem? Esteem software is a total integrated solution computer program that offers the complete package in reinforced concrete design. So for 2D analysis, to run 2D analysis, user shall create a complete key plan. A complete key plan must include grid lines, beams, slab, column, and also stairs. So for the verification, the program shall run auto verification before generating mesh. An error or warning message will pop up if any element that cannot pass the verification. User shall then recheck the key plan and correct the key plan to satisfy the verification. So for the mesh generation, the program shall generate plan mesh after passing the plan verification. So for the analysis, the plan is analyzed after mesh generation. Warning message will pop up if analysis fails. So for the design, in the design stage, user can choose either to design all elements or individual element types such as beam or slab. So for 3D analysis, so verification, 3D analysis will start after 2D analysis. The program will do the following, such as generate 3D mesh and also runs 3D mesh analysis. If any flaw fails in 3D analysis, program will automatically give an error report. So for the 3D post analysis, after the 3D mesh analysis, the program moves into 3D post analysis. Two sets of results are produced here, which are 3D contour view and 3D loading and result view. So the last one is design stage. After 3D post analysis, program will move into the design stage. User can predefine to design all elements when running 3D analysis. So the first picture is the toolbar to enter, which is contain beam, slab, and column. So this is our project reading for 5 story. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hassan bin Matua, metric number DF170057. I will be continuing the presentation with the point esteem structural output and explanation. As the data of the building and the design standard selected with which is the EC2 are being inserted in the software, run design analysis to see whether there are some failures in designing. For example, if failure such as deflection occurs, redesigning should be done for the specific structural member. Example of the structural output is slab output as follows. In the slide, you can see the figures of the slab output from the esteem structural design. Next, the explanation. The reinforcement that are provided by the esteem software are based on the standards of the EC2 and also added with the safety percentage in the designing. The use of beam, column, footing and slab sizes are appropriate as the software does not detect any error. It is not surprising if the results are slightly larger than the manual calculation. The comparison manual calculation and esteem output. For the continuous beam B1 to 7 ground floor, in the span 1 to 2, the main reinforcement used for the for the manual calculation is 4H10 and the esteem software is 2H20. The span 2 to 4 for manual reinforcement used for manual calculation is 2H10 and esteem software is 2H12. Next, for span 4 to 6, manual calculation 3H10 and the esteem software use 2H16. Span 6 to 7, the manual calculation use is 4H10 and the esteem software use 2H16. In this table, you can see that the esteem software design much more bigger than the manual calculation due to the safety factor. Then column corner hash 7 for first floor. Main reinforcement used for manual calculation is 4H12 and esteem software is 4H12. Then pad footing H7, manual calculation 7H12 and esteem software is used 17H10 for bottom, then 16H10 for 17H10 for top and 16H10 for bottom. And lastly, for the two-way restraint slab hash 6 to 7, the manual calculation use size is H6 250. Meanwhile, the esteem software use H10 250 mm. For the conclusion, in general, the manual calculation and esteem software results do not have very large differences. Both are designed as per specification and under the EC2 NA to MS requirement. So it is very sure safe in terms of deflection, cracking, shear and moment. However, there are slight differences in esteem software which it provide bigger value than the manual calculation as it includes safety percentage in its designing procedures. For an example, the reinforcement in column take 0.5% from the area required to be used.
So the last one is what have I gained from IDP course. The first one is this course is introduced to industry process, meaning we are enhancing our employability skill, learning how to be a professional engineer, widening the context of our academic learning, and becoming a more attractive graduate. It's about creating and testing ideas to solve real world problems. In doing so, we will improve our technical knowledge, communication, practical skills, and employability all at once. So the last one is the group work. So from the group work, we can improve our communication, leadership, discussion, planning, monitoring, assessing, peer review, reporting on progress, taking responsibility, and taking action. That's all from our group. Thank you.